Hello, Year 9s. Welcome to Mr. Chan's classroom. So today we will be looking at how to use trigonometry to find angles. Okay, not any unknown any angle, but it is the unknown angles. So to do this, we are required to know three keywords because we'll be using all three of them. It is called, first one is called the reverse operation, or also known as the inverse operation. Okay. Second one is your trigonometric ratio, obviously the tangent theta, cos theta, and sine theta. All of these has a short form of SOHCAHTOA. I hope you remember that from previous videos. And the last one is angles, which is in terms of degree. We have theta, alpha, and beta. They are all interchangeable. So if you have watched the previous videos, we use trigonometry to find the unknown length. Okay. In order to find the unknown length, we need to know the angle, and we need to know one of the length by having numbers on it. So, however, what happens if the angle is not given is we can actually find the angle as long as there are two lengths provided to us. Okay, one condition is you need one condition to find a unknown length is you need to know two length. All right, so these two lengths will be either your opposite, adjacent, or hypotenuse. Okay, so we have to revisit algebra for a quick seconds. So what inverse operation means is you kind of do the reverse of what you need to do in order to find the solution for the unknown. So here we have 3x minus 5 equal to 22. So to solve x, we need to use reverse operation, which I have taught multiple times during our lesson and from last term. Hope you still remember some of it. So reverse operation or inverse operation on this is you need to get rid of the minus. So you need to pretty much single out that x. So to single out the x, you have to do get rid of every numbers besides it, and you have to add or minus or subtract or multiply. Add minus, divide and multiply, but you have to do it on both sides. So if you notice here, we have minus 5, 3x minus 5 here on this side. We need to get rid of that minus 5 by adding 5 to it. So we have to do on both sides. So once we've done that, we will have 3x on our left hand side, and on our right hand side we have 22 plus 5, which is 27. So from there we need to get rid of that 3 to single out the x. To single out the x, we have to divide it by 3. Alright, so once we divide it by 3, that's gone, and we have to do it on the other side. That means 27 divided by 3 is 9. So now we have x equal to 9, which is how we find the unknown out, okay, by using the inverse operation. So with trigonometric ratio, you actually do the same thing. You can actually get a lot of help with your calculator. So the first one, if you still remember, we have sine, cos, and tangent. With sine is sine theta equal to opposite over hypotenuse. The reverse of it is literally just single out the theta and put this across to that side, which will show up as that. So sine to the power -1 is actually not called, it's actually not sine to the power of -1. It is actually called the inverse sine. So you just need to inverse sine and then bracket and then opposite divide by the number of hypotenuse. So if you look at it, it is literally the same way for cosine and tangent. Alright, they all move their cos or tangent to the other side of the equations, and when you move over there, it will change into inverse cos or inverse tangent. Okay, so this takes a bit of time to actually get used to it. In the next slide, I'm going to show you how that works. So let's move on to the next slide. So in this slide, I will teach you how you can use a calculator to operate an inverse function. So to do that, you have to press most calculator have this. If you there are two versions of it. There is you can press second F, and then you have to press shift, and then proceed with whether you're gonna use sine, cos, or tangent. Okay, the other sort of calculator have inverse this symbol, and then you press sine, cos, and tangent, and then from there you plug in your numbers. I will actually teach this explicitly during our lesson, so this is just a heads up for you. So let's look at the example. So here we have a right angle triangle with 43 as our hypotenuse and adjacent of 16. Alright, that is your hypotenuse. This will be your adjacent, and that will be your opposite. Okay, in this case, opposite is not given, but adjacent is given, and hypotenuse is given. From there, we have to find this theta. Okay, so the trigonometric ratio that relies on hypotenuse and adjacent is our cosine, because soc ka toa, okay, ka C-A-C-A-H. So cosine equal to adjacent over hypotenuse. Alright, or it can be written as cos sine equal to adjacent over hypotenuse, but this formulas is for us to find the length, unknown length. So remember, if we want to find angle, we have to do the inverse operation, which is theta equal to cos -1 equal to cos -1 bracket adjacent over hypotenuse. So from here on, we just need to put in the value of adjacent and hypotenuse. So let's put that in. So theta equal to cos -1 16 over 43. So what I will do here is, all I will do is I'll press second F, and then I'll press shift, and then I will press sine, and then from there it will come out as first open bracket. From open bracket, I'll put 16 and then divided by 43, and then I will put a close bracket, and then I will press enter. So after I do that, I get 68 degree, as my answer. So that 68 degree means the unknown angle is 68 degree. And you pretty much got the unknown angle. I will try to show you one more example for this. So second example is a helium-filled balloon. Alright, that's a balloon. A helium-filled balloon is attached to the ground by 24.5 meters string. What happens is there's a light breeze it's blowing so that the base of the balloon is now has a height of 22.6 meters above the ground. What is the smaller of the two angles to the nearest degree that the string make with the ground? So it's pretty much asking us to find that degree. So from there, we will know that the that length become the opposite, which is O, and the longest length 24.5 is your hypotenuse. So one of the trigonometric ratio that uses both of these lengths is your sine. Okay, so sine, first you have to write sine theta equal to opposite over hypotenuse, and then we have to use the inverse operation, inverse sine, which is theta equal to sine -1 or inverse sine bracket opposite over hypotenuse. Okay, this is to find the unknown angle that we are looking for. So from here is literally just putting in the numbers. So sine, inverse sine, your opposite is 22.6 and your hypotenuse is 24.5, and then close bracket. So you're gonna use calculator to help you with that. Once you got that, you will come across the answer as 67.287 degree, which you can round up as 27 degree. 67 degrees, sorry, my bad. And that is your unknown angle. We were going to practice more during our lesson, and I will go around and actually help each and one of you use your calculator to calculate this inverse operation for trigonometric ratio, because this is the first time you come across with that. So I'm gonna finish off the videos today by telling you good job for listening to these videos. We have went through the inverse operation of the trigonometric ratio to help you find the unknown angle. Okay, so which trigonometric ratio inverse you're gonna use, it all depends on which of the two lengths, either the hypotenuse or the opposite or adjacent, has been given to you. Okay, from there all you need to do is put it in your calculator and then you get your angle. Thank you for listening and peace. Bye.